Now, the next section is completely more complicated because these substituents can have either a prefix in the name or a suffix in the name. It depends on who has the priority. Obviously, the one that has a higher priority will have the suffix on its name. So, you may wonder, why is this order that's given? This is actually still on that same page, page 2. We've got carboxylic acid at the top, then we have aldehydes, then ketones, then alcohols, and then amines. This is in the order of acidity, of the general acidity for each one of these. So that's why it's in the order that it is. It's according to the acidity. Now, we had talked about that in class, and we kind of tested on that a good bit, so I hope that you remember how to determine which one's more acidic by looking at it. Esters are not in here. They would actually go below the alcohol, but we'll get that in there when we can. All right, so we're going to kind of work with what they've given us in this naming groups. But let's start out by talking about the two different names. So like with the amines, if it's a lower priority, if it's on the same chain as another one, if it's a lower priority, it's called an amino. And if it's the highest priority, it's going to be an amine. Okay, now, where would this show up? So this would be the prefix, and this is a suffix. So where this would show up is if you had an alcohol that had an amine group, an amino group on it, then the alcohol would take the priority over it. So if we had 1, 2, 3, 4, let's do this, and let's say we've got an OH group here, and here we've got an NH2 group. See, the alcohol is more, it has a higher priority because it's more acidic. The hydrogen on that is more acidic. So it would wind up with the name of the alcohol. So we would number this so that the alcohol had the lowest number, 2, 3, 4. So we have 4 total, so that's going to be butanol. And that would be 2-butanol. Now starting out, it would be 3-amino, 2-butanol. And I don't know why I did that on 2 different lines. 3-amino, 2-butanol. Go in the other direction of this, let's draw a very similar compound. Let's number 2, 3, 4. And here we're going to have a chlorine, but let's put that amino group on here, NH2. And in this case, you see the amino group has the priority because the other is just a halogen substituent. It's from a different group even when we're naming those groups. So we would number this one from the opposite direction, 1, 2, 3, 4. The amino would take precedent over it, it has priority. And so in this case, it would be 3-chloro, and then we would have 2, and then this would be butamine. Nope, I said 2-butamine. I have to say but-2-amine. Butan-2-amine. Sorry, that's my mistake. I'm not perfect. So that would be our amines, and that's how that would fall in place. The next one up here is alcohol, and alcohols have the OH group on them. Our prefix on that is hydroxy, and the suffix is ANOL. Well, I say ANOL, but it's, according to theirs, it's just OL. So let's look at an alcohol here that would have the hydroxy group. So let's go 3, 4. Let's double bond this. Turn this into a carboxylic acid, because the carboxylic acid is higher in acidity. So it would take the priority there. And let's put our alcohol on there like that. I know that gets really complicated, but work with me here. So we count our carbons, and we would count from the carboxylic acid side. 1, 2, 3. There are only 3 carbons in this, and so this would be propanoic acid. One propanoic acid, actually. And then we have our OH group is on the second carbon, so it would be 2 hydroxy. One propanoic acid. I mean, there's really no other way that could be named, but we could leave the 1 out, I suppose. Now, if we drew the same thing with a hydroxy group on there, and then let's say over here we had a methyl group on this one, we would number it in the opposite direction. So we have a hydroxy on the lowest one, and so here this would be 3 methyl, because our methyl group is on the third carbon, and then it would be 2 butanol. With the same thing keeping in mind, what if we had 2 alcohols on it, or even 3 alcohols in this case? We go with numbering it from the side that has the lowest carbon number for the substituents, 2, 3, 4 in this case, so it's going to be butanol of some sort. We would count this out. We have 1, 2, 3. And so we would number this as 1, 2, and 3. 1, 2, 3. Butatriol. Butatriol. I love that. That's a really cool. Anyways, so that's your alcohols. Next, coming up after that would be our ketones, and ketones have a double bond. It's going to be R, the carbon to oxygen double bond with R prime. R and R prime could be equal. And then our prefix would be oxo. That's if something else has higher priority. And our suffix would be -one. So if we have this character here, we have 3 carbons, 1, 2, 3, and then we would just name this one as propanone. Propanone, because it's 3 carbons, and there's only one place that the double bonded oxygen could go. If it went on the end, it would actually be an aldehyde, not a ketone. So that would be propanone. So if we had in the case of an aldehyde, which is the next group as far as acidity is concerned, if we had this very similar thing here, and we had a double bonded oxygen here, and then here we had a double bonded oxygen, we'd have an understood hydrogen that's here, and that's our acid hydrogen in that one. But I'm going to take that one out just because we talked about it. All right, in this case, no longer is it just a ketone. We also have an aldehyde. And so the aldehyde ends up with the suffix of just Al. So in this case, instead of being propanone, this would be 2-oxy propanol. So when we're talking about formaldehyde, that's the aldehyde. That's what an aldehyde is there. 2-oxypropanol Propanal. I know that's a really weird word to say. And the rest of it kind of falls in place like it does otherwise. Let's put this in here because we haven't talked about a cyclo yet. But let's say that we've got this particular creature. It's a 6-carbon ring, and we have a double bonded oxygen. That makes this a ketone. And then over here we're going to throw a substituent. Let's put an ethyl over here. So in naming this, the same idea takes place. We want the lowest number possible on our highest priority group. 2, 3, 4, 5, 6. The ring gives us a cyclo prefix. So in this case, we would have 3 ethyl. Okay. That's because this ethyl group is on that 3rd carbon. And then we would say this is cyclopropanone. Cyclopropanone, hexanone. And we don't have to number the hexanone. We don't have to number where the ketone is located because there's only one, and it's understood that in this molecule it has the highest priority, so it has to be assigned the lowest number possible, which is 1. Aldehyde, those can be named 2 different ways for the prefix. And that can be oxo or formal. And in the suffix of the aldehyde, it's going to be named with the AL. So let's throw a ring on here. 2, 3, 4, 5. It's a 5-membered ring. Oh, you know what? We can't do an aldehyde with that unless we do it like this. Yeah, that'll give us another opportunity. So here we have an aldehyde, takes the highest priority. So in that case, since it has the highest priority, our chain only has 2 members. That turns this cyclopentane into a substituent. Okay, so here we have 1, 2, so that's going to be methyl ethyl. It's going to be ethanal. Okay. And then it's going to be 1, 2, and on the 2nd carbon we have a cyclopentyl. So we have 2 cyclopentyl. Oop, ran out of room. Hold on, let me move that out of the way. Ethanal. Wow. 2-cyclopentyl ethanal. You see that even though there's more carbons in that ring, it's not the longest chain because we had to give the priority where the priority is required. Now, at the same time, if we had this molecule, and then this was an OH group, see, that's our carboxylic acid again. That has the highest priority on our list. And then over here we had a double bonded oxygen. We'd also have an aldehyde down there. In this case, we would name this, we got a counter carbon, so we have 1, 2, 3. We count it from the side of the carboxylic acid. And so 3, so that's going to be propanoic acid. Propanoic. And then our aldehyde would be a 3-oxo propanoic acid, just like that. Now, if you haven't caught on already with the carboxylic acids, they're always going to be on carbon 1. So that's why you'll never see propanoic acid with a number on it or butanoic acid with a number on it. You could have a diacid where you've got a carboxylic acid on two ends of a chain. But once again, you wouldn't need to number it because it has to be on the end of the chain. So that's a very special case. But the next item on there is the carboxylic acids. And if you need to name that with a prefix, which I personally cannot think of one just off the top of my head, that would be carboxy. And as you've seen before, it's oic acid. So let's draw one out here that's for a good example. And let's put some substituents on there, a methyl and a chlorine on that one. So in this case, we would number these starting with a carboxylic acid carbon, 2, 3, 4. So that's 4. So that's going to be butanoic acid. We got a chlorine and we got a methyl. Chlorine would come first. So it would be 3 chloro, 3 methyl. That's our methyl group right there. And then it would be butanoic acid. Now, if we had a ring of sorts, we have to use a different subscript on that one. I mean, suffix. I said subscript. Yeah, it's been a long day for me. It's only like 11:30. So if this were carboxylic acid, out here we have cyclopentane. And the carbon isn't part of that longest ring, but it's not a substituent to cyclopentane, so we would actually name this as cyclopentane carboxylic acid. Just like that. And I'll leave a space there. I don't think you're supposed to leave this space, but I will. It's not like anybody's going to sue me. I hope you don't sue me. All right, so that gets us all the way up to carboxylic acids. In a moment, I'll talk about some special characters.